So apologies, this will be a first for us. We are going to do a presentation without slides. The projector doesn't seem to like neither our Linux or our Windows laptop. First, let me tell you that we are releasing a paper with this presentation. So obviously we are going to miss the detail without the slide. We have already lost some time, so we won't also miss more details. So go read the paper. There's a lot of information there. So basically, what was this talk about? Basically, we are releasing a tool to audit the CAN devices. And we were about to present why we needed such tool and what you could do with this tool. Okay. The very idea of this tool is to come up with the one particular fact. When you want to edit a protocol, you have two options. Either you reverse the whole protocol from scratch, you have to understand everything, or you let, for example, legitimate clients do most of the communications, but because you are able to set a man-in-the-middle configuration, you listen to these legitimate clients doing the communication, and at the right moment, you start blocking packets, modifying packets, replaying packets. The very idea of this approach, the man-in-the-middle approach, is really to let legitimate clients do the heavy work. This way, you don't have the need to reverse everything, and you start playing with data, trying to exploit vulnerabilities at the right moment. The very problem with the CAN network is that it is a serial bus network, meaning that you cannot do this. For example, if you do this for web application, you simply set up Burp Suite or Zap Proxy, that kind of tool, and you are in fact intercepting every information. You can modify them also. With a CAN serial bus, you cannot unless you physically cut the bus and insert yourself in between, or you plug out one particular device, the one device you want to audit, and you build a CAN bus just for this device, and you put yourself in the middle of these two buses, and you start forwarding from the packets from these two buses, and when you're ready, when you think it's the right moment, you start modifying or replaying packets.
Okay, so what was the objective of our tools? So there was already other tools to work with CAN. They were mostly based on UART over USB. It's quite slow. It can't handle the full speed of CAN, which is 1 megabyte, and nevertheless 2 CAN interface. So we cannot just use two serial over USB tools connected to a computer and in the computer to do the man in the middle. We had to build new tools, which is CANSPY. So about CANSPY, what we need 2 CAN interface to do the man in the middle, either also to sniff and inject. You can also do that. We need to be able to forward frame from CAN 1 to CAN 2 and from CAN 2 to CAN 1. And we want also to be able to filter, to trigger a frame and change the value because we want to pen test. And what we want to is Ethernet, because we want to use standard tools such as Scapy or Wireshark, and Ethernet is quite convenient, and also it has the required speed for 2 or even more CAN interface. So our tool is based on Ethernet. We also have a serial port. You can still get the frame on a serial port, but this is more for debug purpose. We can also store the settings of the tools in an SD card in order to be autonomous, to put the tools in the car without connecting a computer and logging the packet, for example. About CANSPY hardware, we want to avoid any complex soldering for people in order that everyone can use these tools. So the main board is a demo shield, a demo board you can find on the internet. So it's on the slide, so you will need the paper to find the reference. And we use a shield that provides Ethernet connector, SD card, serial. You can also find it on internet, on Mouser, DGK, and both are less at 60 bucks, I think. But you will still need to solder a small shield because we did not find any shield with CAN interface, so we have to make it. But it's really simple. It's mostly jumper to set up several settings, either if you're working on the real car or you're working on a bench. So you have to set up resistors, power supply, etc. And everyone can solder it, and it's also cheap, less than 30 bucks. So the complete tools is less than 100 bucks. It depends on where you build everything. Okay.
Actually, if you don't want to solder the CAN shield, we have some spare shield for people who want to try it more quickly. So yeah, come at the end of the presentation, and you can see actually the tool. We have two tools running there. Yeah. We're going to talk about them. But for example, we have one that is emulating a car, and the other one that is doing the man in the middle setup. That is basically what you need to edit a CAN device without auditing the whole car. You need either the capability to emulate the whole car to make the device think it's at home, and you need to have a tool doing the man-in-the-middle attack, so you can modify a packet on the fly. So we have here a bench with one CANSPY doing the emulation, emulating the car, and one doing the man-in-the-middle attack. For example, I have my phone here with diagnostic tool, thinking we are currently driving at 15 kilometers per hour, and that is the first CANSPY doing the emulation. And at any moment, at the end, we are going to set up the man in the middle and to activate the internal filtering engine to ask him to modify the speed so that the tool thinks we are driving at 255 kilometers, which is the maximum according to on one byte pack.
It's a cheap OBD-II dongle connected to Bluetooth, then a free application you can find on the store.
The idea is I guess we missed a bit of introduction. Actually, we are working with car manufacturers to help them find vulnerabilities before their embedded computers that they want to put in car are put in the market. That's why we built this tool. Like I said, doing a man in the middle, you need to physically cut the bus or extract the device. If you're doing this at home, that means you have to take apart your car. But we are helping car manufacturers, so they gave us access to integration bench, where it's easy to plug in or plug out the CAN devices. They can give us specifications, so we can build the car emulation software quite easily. But the reason we choose for today to use the OBD-II case is that it's easy for everyone to do the same as we do, but at home. You don't need to cut anything or to unplug anything with the OBD-II case. You just need your car, an OBD-II device, a cheap diagnostic tool, for example. You can set up the CANSPY tool in between your car and the diagnostic tool, and then you can start playing with the device. A little tip, if you want to turn around a security issue that is usually considered, people try to attack car. Why not attack tools that are connecting to the car? This tool can be pretty sensitive. For example, if you manage to compromise a diagnostic tool, the other car that will be connected to this diagnostic tool will be at risk also. One easy way to do this is to play with diagnostic requests which answers are fragmented over multiple CAN frames. Because the diagnostic tool usually defragments those frames to extract the payload that was initially sent by the car. And if it's easy to induce buffer overflows at this point. tools always expect the car to be compliant with the norm, which is true. I've never found a car that was not compliant with the norm. But if you put a man-in-the-middle device at this point and force, for example, the vehicle identification number, which is 17 ASCII characters long, to be up to 40,000 characters, you will induce a buffer overflow that can be exploited pretty much like any buffer overflow.
Yeah, just an obvious information, but everything is open source and open hardware. You can find it on our Bitbucket. You will have to search on Google. The firmware has been designed in order to simplify adding new functionality, because maybe you want to add new function on the shell. For example, we have a serial shell with it's used to change and manage settings, but you can want to add a new functionality. So when designing the firmware, we really think on how we can add new function.
A little word about this firmware. As you may have understood without the slides, we have two CAN devices. Did we talk about the internet? Okay. We have two CAN devices, one Ethernet device, one UART device, one SD card driver. In order to never miss a frame, that's really our goal. We want to forward the full data rate, that means up to 1 megabit per second from two CAN buses. We want to forward frames between the two without dropping a frame. So we had to design the firmware using real-time techniques to achieve this goal. If you add new functionalities to the tool while complying with our abstraction layer, you can add functionalities and be sure that you will not impair the real-time properties of our tool.
So we skip a large part of the talk where we was talking about CAN architecture, but without slide it will not be possible to explain, I think. So
we can try.
Yeah, so
let's try.
Yeah, let's try. So a few words about CAN architecture. So what you can find in a car. So the most basic one is one single bus with every EQ. So EQ is an electronic control unit. So in your car you have up to 70 control units for controlling the dashboard, the brakes, the engine, etc. They are all connected, and if we think of the most basic architecture, this is just one bus and everything connected. So as you can imagine, you will have congestion issue, because if everyone is talking at the same time, someone cannot talk. So the mechanism is based on ID priority to select which frame will be sent if two EQ are talking in the same time. The lowest ID is the most priority, it's the highest priority, sorry. But as you can imagine, an EQ that have a really low priority will never talk. So it's in a most advanced architecture in recent car, you have several buses. So another point of having separate buses is to try to segment, for example, with one bus for the entertainment, the navigation, and one bus for the engine and the brake. So this was more thinking for safety than for security, but it's still good for security. You can have, again, two possibilities. There are two buses with EQ on each bus, and EQs that are connected to two buses. For example, for the navigation system, it is related to the entertainment, but it also needs the speed and information from the car. And what we can think as state-of-the-art architecture on modern car is with several buses and gateway between these buses, so like an Ethernet network. And this gateway will filter the message based on their ID, but they can be a little bit smarter and use the state of the vehicle. If the vehicle is stopped, if it's running, which speed it is running, if the engine is off, etc. And they will allow different ID in function of the state of the car. So we can see that this is something with we can play.
The idea is that for an attacker, you have first the exposed ECU, for example, navigation system or telematic functionalities, using broadband, mobile broadband communications. And once you compromised either of these two types of ECUs, in order to really impact safety, you have to compromise more ECUs. but usually these ECUs will not be on the same bus as the ECU you just compromise. So you need to move from one bus to another, and the idea is to compromise an ECU that is either on multiple buses, like the first case Arnaud presented, or if you are in a situation where you have a central gateway, to compromise this gateway. And that is essentially the goal behind our tool. It's not about auditing a navigation system, you know, compromising Bluetooth, Wi-Fi, USB, mobile broadband. It's really for the second line of defense, to audit ECU from the CAN bus. The idea is to craft attack from the CAN bus, not compromise an ECU from Bluetooth, for example, and reach the CAN bus. That is the first step. It's an important step. We do that step 2 when we audit ECUs, but really there's nothing to add here. I mean, if you want information about Bluetooth penetration testing or Wi-Fi penetration testing, there's already plenty of tools, plenty of literature to explain everything.
On the broadband-II, you can find a lot of data about broadband pen testing. It's not specific to automotive.
Usually, you just end up building an IMSI catcher to force the ECU to use your own mobile broadband, and again, you set up a man-in-the-middle attack, so you can try to modify the information coming from the car manufacturer infrastructure and see what happened on the car. Man in the middle is really the way when you want to find and exploit vulnerabilities very quickly, without the need to really understand everything. This is something that was lacking to us from the CAN perspective, doing CAN attacks from the CAN bus, and that's why we ended up building this tool. I'm just working at the time. Okay. Do you guys? Is there anyone that has questions?
Yeah, we have the demonstration running here. So since we have time, I guess we have. Yeah. You can come and see the demonstration running. We have no camera to show this, and the screen of the phone is not large enough for everyone. So. And if you have questions, of course, you can answer. And again, we apologize for this issue. We tried on 2 computers, Linux, a Windows, and it was working on the speaker room. So, well, that's happened.